Welcome to SIM-PAC Live. I'm your host, Geoffrey Matthews. Today we talk to Tony Collister from Danbar Plastics Fibre division about the increased use of recycled fibres in light infrastructure. Welcome, Tony.
Thanks, Jeff. Nice to be here.
Tony, can you give us a brief background on yourself and your history? Because you've actually started inventing some of these products we now see in more common use. Tell us the process of how you started down this track.
Okay, well, it's an interesting story. I'll go back to the start and give you a full overview. I had a private school education down in Melbourne. It was one of Australia's more ritzy schools. Started engineering at what is now Monash, but was back then Caulfield Institute. Much to my father's disgust, I decided to leave and become a concreter. So I've worked in the concrete industry for, it's up to 40 or 5 odd years now. I've worked as a concreter for many years, a finisher, placing a lot of concrete. I did most of my training down in Victoria, and now I live in far north Queensland, in Townsville. About 25 years ago, actually, I started to get involved with fibres with a gentleman by the name of Mark Combe, and started using them myself, introducing them to the marketplace up here in North Queensland for general works. That was a steel fibre at the time. Then I decided to look at what was going on around the world, and we noticed that there were some macrosynthetic fibres. Now, to give you a bit of an understanding, a macrosynthetic fibre is a plastic fibre that is about the size of a matchstick, and we mix them into the concrete. So I got involved with doing the macrosynthetic fibres. Working with another company, we approached Danbar Plastics to actually make fibres for us. And then back in about 2013, we come up with the idea of why can't we make these out of recycled plastic? So from that, we achieved that around 2015-16. Since then, they've been growing in the marketplace up until now. I used to work for another company, but now I work directly for Danbar Plastics.
And this technology, 100% recycled plastic, tell us how it can positively impact the CO2 embedded in the final product.
Okay, so the most common thing that we've got currently at the moment where we use macrosynthetic fibres is things like footpaths, shed user paths, your car parks, what we call slab on ground applications. In those applications, we put mesh, steel mesh, which most people have seen, and that's there to control any shrinkage cracking that may occur. And the steel mesh is in there to hold those cracks together once they've occurred. What we do with the macrosynthetics is we mix them directly into the concrete and we replace that steel mesh. Now, if you can imagine, we've got hundreds of thousands of tiny little plastic reinforcing bars mixed three-dimensionally all the way through the concrete. So when the cracks start to occur between the aggregates, before you can see them at the surface, the actual fibres are there to resist and hold those cracks together at a very fine micro stage. So by doing that, we've actually achieved a better performance. We've got an environmental product declaration, what's called an EPD, for our repoly plastic fibres. So to compare in a CO2 comparison perspective, we can actually quantify from, say, an infra build has probably best in class CO2 for their mesh. We can then compare, say, in 100 square metres, 100 mil thick footpath. We know how much steel mesh goes in that. We know how much repoly fibre goes in there. we can compare the two, and it will come into round about 89% carbon reduction for the reinforcing versus reinforcing.
Yes, because it's versus steel.
Yes.
Yes. And 2 points. I want to just jump back quickly to the 2013 decision to start using recycled plastic. Was that a conscious decision because you saw we were too much plastics in the environment, or was it a readily available resource that you thought, well, we could just jump on this?
Ironically, it was my grandfather who used to always have this saying that one man's waste is another man's wealth. And my father had taken that up in a different role, in a different thing completely, and actually, as an accountant, introduced something that was quite obscure to being an accountant. And so I asked the question, can we make this out of recycled plastic? Because we were making the fibres out of virgin plastic. And just so happens that Danbar Plastics have been making elements from recycled plastic for 30 years now. So they had a lot of knowledge in that space and were able to bring that technical expertise. So we were able to actually create the product. We sponsored a PhD at the time to, if you like, get credibility from academia rather than us saying to market, here you go, we have a product, we believe it's better. You've actually got a situation of where once you've done a PhD, you have academia, you get that credibility, if you like, and people are happy for that independent review.
Yes. Now, your environmental product declaration, how important, well, how difficult was it? How important did you think it was? You've obviously put the effort into doing it. How important is this stuff going forward for other people, for other products that want to be able to feed into these, especially major infrastructure projects?
That's a good question, Jeff, actually, because it's probably very relevant. The framework to get the recycled products into infrastructure, when we first started, was pretty sketchy, to be perfectly frank. We were probably lucky with the fact that Vic Roads had a specification for using macrosynthetic fibres in applications like shared user paths. So therefore, there was a framework, a set of tests, etc., that needed to be done. And then we were able to go through that process, achieve that. And then the EPD was pretty much almost like probably a good way to describe it is it's a ticket to ride. You've got to be 5 foot tall and have a blue shirt to ride the roller coaster. So the EPD is the blue shirt, if you like. It meant that major projects were able to use it. They can then give a very good comparison compared to what they're actually got in steel. So we've got an apples against apples.
Yes, and without it, you really, I've forgotten the word, but you're really the magician at the circus trying to sell something.
You're making false claims, technically.
Yes.
And Infrastructure Sustainability Council, which is someone I've sort of had a lot to do with, was one of the very early adopters in that space, have a motto where we can't manage it if we don't measure it. And I actually very much like that. When not everything is going to be absolutely 100% sustainable and be able to reduce the carbon of everything. However, if we measure it, we then actually have a framework, or a baseline.
Yes.
But if we don't measure it, well, we're talking pie in the sky.
Yes, exactly. Tell me, how much concrete do we use in Australia, and then how much of this could use recycled materials in it?
Okay. Approximately a cubic metre of concrete for every person in the country is a rule of thumb that we've used for many years in the concrete industry. So we've got...
And a cubic metre is how much in tonnes. I know a
Two-
cubic
two-
metre is a tonne of water, but
2.4 tonnes for concrete.
yes.
So 1 cubic metre weighs 2.4 tonne. That's dry.
Yeah.
Okay. Yeah. Approximately, I think, what have we got? About 26, 27 million people now in Australia. So let's round it down to 25 million because it's an easier number to work with when it comes to that. We've probably got, maybe this is conservative number, 5% of that concrete would be for footpaths and shared user paths, bike paths, that type applications. So, when you're looking at that, and I wrote some little numbers down here for me yesterday so I could give these to you relatively accurately. If we were to use them in a 100 mil thick footpath, where we were using, say, 4 kilograms per cubic metre of the repoly fibres to replace steel mesh, we would, in the end, probably have about 1 million cubic metres of concrete potentially that we'd be doing. Now, I ran a little comparison between the EPDs of InfraBuild and us last night, just to give you some numbers. And if we were to do that 1 million cubic metres, which would be 10 million square metres of footpaths, right, over a 12-month period, we would save 56,500 tonnes of carbon.
And Tony, tell me the current limitations you have. Where does the engineering cut off that you have to go and use steel versus microsynthetic fibres? And do you see a future that you can develop these recycled materials further to be able to use that, extend that 5% to 10% or beyond?
We use the macrosynthetic fibres for what we call shrinkage crack control. So that's sort of the first thing we need to sort of have everyone understand. Same with steel mesh. It's for shrinkage crack control, and it's mainly for elements that sit on the ground. So they're basically ground supported. They're what we would class as non-structural. And the definition I'll use for structural is something that's, say, sitting in the air, like a bridge or a high-rise building or something like that, where they actually have what we'd class as, bending moments from stress, etc., which are very different to what we got with a slab on the ground. If a slab on the ground bends and needs reinforcing to compensate for that bending, it's basically too thin when it comes to design. So macrosynthetics, there's probably 3 areas where we use them commonly. That slab on grade area, which is the most common. Shotcrete, underground sprayed concrete in the mines, etc. And that's mainly virgin fibres because they're chasing a fairly high performance. And the other area is precast applications. And those precast applications are things like pits, wing walls, stuff to do with storm water, that sort of precast, not your precast walls, but your smaller elements. Now, they're a hybrid design where they might have one bar in a, say, normal pit. We would take all the mesh that would be normally in there out, use fibres in that circumstance, but still keep that one bar. To take them to the next level will always only be in this pretty much non-structural area because what we're looking for with structural concrete is what we call strain hardening. Now, that means that if the concrete cracks, the load that's exhibited on it can still keep going upwards, even though the concrete's cracked. And that's where the steel reinforcing bars are playing their role. Now, steel mesh is no longer what we call ductile, and so therefore it actually will snap at fairly large deformations. So it's no longer used greatly in structural concrete. It's, as an example, in a suspended slab, they might have mesh there, but it'll be basically to give them the centres to tie the bars to, if you like. The mesh is 200 square. They'll tie bars to every bar in the mesh. So it just makes life simple for the steel fixers in that sense. But comparing the two, macrosynthetic fibres are mainly there for shrinkage crack control, and that's their predominant use.
Right. And are you looking to develop other products from recycled materials? Well, what's next on your horizon?
Well, we do have another product in the works at the moment that I actually can't talk to you about because it's a little under patent application at the moment. But one of the things I am looking at and working with is a concrete that they call ultra high performance concrete. And we're about to undertake using macrosynthetic fibres in that, which is sort of it's a concrete that has minimum strengths of 150 MPa, compressive strength. And we're looking at using macrosynthetics in that potentially to see what their performance, that would open a broader realm for using macrosynthetics.
Right. And I know the circular economists out there will want me to be asking this question. What happens in 50, 70 years when you need to recycle this concrete? Have you got a way of getting those fibres back out, or is that sort of will we reinvent that down the road? So we've got 50 years to think about it.
A little bit of both, to be honest with you, Jeff. Currently, at the moment, concrete will be crushed up and recycled and is now being used with other materials in blending as road base. So under EPA laws, and the most stringent of those is New South Wales, where you basically can have up to 0.2% of deleterious plastic in your road base. That would convert to 5 kilograms per cubic metre of plastic fibres. If you were to take 1 cubic metre of concrete, crush it up and use it solely as road base. That never happens because it gets mixed with other concrete that doesn't have fibre, gets mixed with road-based materials. So currently at the moment, it can be used in that circumstance. Once the recycling companies start to become more mature, it's probably the best word to describe it, and they start putting washing plants in where they actually want to wash their concrete after they've crushed it to get better value for the materials, then the plastics will be able to be floated off and they could go to another waste stream.
Right.
So it's a little bit about the maturity of the industry, Jeff. Yes.
I mean, what you're saying, there's no technical hurdles at the moment. It's just it's process, and as it becomes a resource to recycle, it'll get better and better.
Yes.
I want to talk now about cement. Now cement is the glue that makes concrete.
Yep.
And I've got to admit, I until I got to know you, Tony, I was very guilty of mixing cement and concrete in my mixed metaphors, if you like to speak. But concrete is one of the world's hard to abate sectors. The cement making particularly in it, and this glue that goes in it, and it's hard to abate because it's big. 7% of global emissions.
Yep.
It involves process emissions. That is a chemical reaction that happens when you make it.
Yep.
And we haven't found our way around that, although there are a number of companies working on it. And, it's only a matter of time, I think, that the chemical scientists among us will find a way through that. And then there's also the energy involved in heating it and making it, and that energy is particularly difficult because it's high temperature heat.
Yes.
And as we know, you've got to burn stuff at high temperature heat. It may not be able to be electrified directly, but we certainly can use biogas, we could use hydrogen, green hydrogen, and some other renewable fuels that come on eventually. But one of the things I'm interested is in, and I've got a couple of SIM-PAC Live members that are in making roading and asphalt, and I know it's different from concrete, but I was fascinated with what they were doing. They are using pyrolysis to make biochar, carbon black, out of natural waste, sugarcane waste. After we've harvested the crops out of it, they burn it in a low oxygen environment, which dramatically reduces the CO2 that it would naturally emit in the atmosphere, and then they're embedding that into the asphalt, making a better product. They can make a carbon negative road, and it's actually cheaper as well. Is there an equivalent in the concrete world? Because I've heard about this carbonation. Can you take us through that?
Okay. Carbonation is a natural phenomenon that actually occurs with concrete. If you've had anything to do with any concrete or seen a drawing, for instance, of plans, you might see that on the drawing, there'll be a layer of steel in the concrete, and they'll have a clause somewhere stating that they want a minimum of 50 millimetres of cover. The 50 millimetres of cover is to protect the steel from the atmosphere, if you like, for the chlorides, etc., and the oxygen. It needs to be in a fairly high alkaline environment, and it stays. It's what we call the passivation layer around the steel, and that needs to be protected so that the steel doesn't rust. In simple terms, now carbonation has always been a nasty in the concrete world because it slowly, if you like, penetrates the surface of the concrete at approximately, say, the square root of time. So let's say if you have 1 year, you might get 1 millimetre depth of carbonation. Go to 9 years, you'll have, say, 3 millimetres of depth of carbonation, etc., etc. Now, that will change depending upon the type of concrete it is. But basically what it means is that the concrete will absorb carbon dioxide through a reaction with the calcium hydroxide that's still in the concrete, that's, if you like, a free chemical in the concrete. In the presence of moisture and in quite humid situations, it will actually create a reaction which produces calcium carbonate. Now, that's technically limestone. What that does is it reduces the pH of the concrete. All right? Now, the pH of the concrete is normally around 13, 14. It'll reduce the pH of the concrete, which allows the carbonation front, if you like, to actually get through the surface of the concrete faster. Once it gets to the steel, it actually makes it rust. So if we've got no steel in, say, a footpath or a pavement, this is something I've spoken with many academics about and sort of thrown the challenge to them. With macrosynthetic fibres, we're not affected by a pH that's dropping in the concrete. So we could actually potentially make concrete that actually carbonates faster than what we currently do. Now, over a 50-year life, let's say, for a pathway, a bike path or something along those lines, we have the potential to not maybe totally absorb all the carbon that was created to produce it currently, but a percentage of that will be actually sequestered. So as you brought up, there are companies out there now trying to actually produce much lower carbon cement by using different processes. as they reduce that, the carbonation offset of concrete sitting out in the weather starts to actually play a role, bring it closer back to neutrality. So the holy grail would be a concrete footpath that could absorb the amount of carbon that is produced to make that concrete. That would be the holy grail. And if that was the case, then all of our infrastructure then becomes a carbon sink. It's not something that's been taken into account for a long time. And I use a slide in many presentations that I do and I use the Colosseum and the Pantheon, and the dome at the Pantheon, which are both basically plain concrete structures. If they're still standing 2,000 years later, carbonation has actually made them very hard, a little bit more brittle, but very hard because of the calcium carbonate that will have been created through that process. However, their pH is probably maybe 8, 9, and if there was steel in there, they would have disappeared probably 1,800, 1,900 years ago.
Yes. No, and I have read articles about the Roman roads and the Roman structures and the concrete absorbing carbon.
Yeah.
So that would be great to get back to that. And it wouldn't be sort of ironic that recycled plastics is what's going to allow us to build concrete like the Romans built it.
Yes, we are working with other cement systems, and one of those that's been currently sort of experimented with at the moment is called calcined clay, where they're basically cooking clays. Yes. And using it to create the cement, a type of a cement, or what we call pozzolan, to replace cement. So, and it has some promising outlooks.
Yeah, and this leads to a really interesting question for me. Is all of this development, which is fantastic, by the way, when did you see a mood change that people stop sort of talking about it? SIM-PAC talks about no blah, blah, blah. And, there was an era there that was blah, blah, blah. What was firstly an era of the Wild West where there was, any claims was out there. And then there was a lot of blah, blah, blah. But we're actually seeing companies doing real stuff and research really looking at the future. When did you, as a person that's been out there for all those years, when did you first start to sense this is actually really going somewhere?
Probably around 2012, just watching what was happening around the world, where governments were going, you know what, we need to deal with CO2. We need to put, whether it be carbon pricing in, those discussions were held everywhere. And that momentum at that very high level, and especially in the finance world, Jeff, and you, someone who's been in business a long time, I'm sure you'd understand what the finance world actually requests often is what drives where everybody goes. And as I got more involved with it, I started to see that some of these very big major projects were getting incentives from the finance world that if they actually created a much more sustainable end product, infrastructure product, that there'd be potentially interest rate benefits for them when it came to large loans for these projects. So the incentives started to be put in place. And then the Infrastructure Sustainability Council of Australia sort of started to get more prominence. They actually started to rate projects, and governments were saying, well, we want this. So I sort of saw a wave coming, and I suppose back in, say, 2018, 2019, I was still saying to people, this is what's happening. There were still many, many people out there going, oh, look, can you please be quiet about this sustainability stuff, Tony? You're starting to drive us mad.
Yes, well, be quiet, or we'll go away.
Yeah, but it did happen. And
it did
and now
happen.
and Victoria opened the door probably with the big build, where they actually created a group called Ecologic, which was basically their mandate was to implement their buy, recycle first policy for the Victorian government infrastructure. And that's really put a platform there, economies of scale. So instead of just banging on the odd council door or what have you, major projects were using things like our products, and hence the momentum was created.
Yeah. Yes. Look, there was an atmospheric scientist, one of the leading ones in the world from Boston University, and this is a few years ago. And he was asked, well, what can the ordinary person do at home when we started to really face up to these challenges? And he said, the number one thing you can do is move your retirement savings, your superannuation savings, move them into a fund that doesn't invest in fossil fuels. And if everyone did that tomorrow, all the problems would be solved. And it was interesting you referencing the finance, because those large infrastructure projects are long-term projects.
Yes.
They're what people love to invest retirement funds into, because they're long. And I can actually see how the industry was pushed along by these green retirement funds that were it didn't want to invest. And young people today don't want to invest in something. They don't want to put their retirement savings into something that's going into supporting fossil fuels.
Yeah. Well, the secret. Well, we were lucky with our recycled plastic fibres, where we actually obviously have that, carbon reduction. We're saving time. So therefore, the project can be actually, our part of it can be done faster. People are saving money, whether that be the contractor who's doing it, so you've got to have that. It's got to end up trying to be a bit cheaper.
Yes, and I would imagine too, there's also less weight to freight around as well than steel.
Yeah. Oh, look, there's a number of unquantifiables that I can't put a number on it. But a good example would be, we did a project where I live in Townsville, where there's just a little traffic island, a roundabout with I think 4 or 5 little traffic islands around it, the little triangular shaped ones. I spoke to the guys. There would have been maybe 30 cubic metres of concrete in the whole project, so not a big project. I asked the guys at the end how'd they go, and they said, we saved $10,000. And I went, how did you save $10,000? They said, well, it was costing us $5,000 a day for traffic control for the intersection, and we got the job done 2 days quicker than we estimated. So that indirect saving...
Love it. It pays for itself.
Yes. So in that indirect saving, that's that case, So, the savings, and the other part that came into it as well is that the social inclusion side of things, where the projects are now trying to actually create that. And all our products are packaged by people with disabilities. So,
yeah, look, it's great to see. Tony, that's all the questions I had for you. If anyone in the audience has got any questions for Tony, but Tony and I will be online for the next 20 minutes or so. You can put them in the live chat below on YouTube, and we'll answer them away. But Tony, thank you for coming on the show today. It's been great chatting with you.
Mate, it's been a pleasure.